Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, here's the last homework that we have for chapter 1 before we get into study mode for the chapter 1 test. M&Ms for this are equivalent fractions, and I feel like we've talked about equivalent fractions a fair amount, so this should make sense. Equivalent fractions are basically two fractions that have the same home on the number line, but the ratios are different. And you get to those equivalent fractions by multiplying by a giant 1. So 2/3, where you can see here, 2/3, because 2 of the 3 equal portions are shaded in. If you were to cut this vertically four ways, then this would end up being 8/12, because what you've done is you've multiplied the numerator and denominator times the same number. So this is your giant 1. 2 times 4 is 8, and 3 times 4 is 12. And you can see when you draw the picture, it verifies the mathematics of your giant 1. So we use the giant 1 to help create equivalent fractions. And remember, one way that you can tell if two fractions are equivalent to each other is to do a cross products kind of multiplication. So I will take 2/3 and 8/12 and set them equal to each other. And when I cross multiply, 2, let me go ahead and do it this way, 2 times 12 is going to be 24, and 3 times 8 is also going to be 24. So anytime you're looking at two fractions and you want to determine whether or not they're equal to each other, you can just do the cross product. So let's take 5/7, and let's take, say that's equal to 25/33. Okay, I already know that's wrong because 5 times 5 is 25, but 5 times 7 is 35. So this is going to be wrong. So when we cross multiply, our cross products will be wrong as well. 7 times 25 is 175. And 5 times 33 is 165. Because they are not equal to each other, these two fractions are not equivalent fractions. All right, so on the topic of equivalent fractions, rewrite each fraction below in at least two different ways. Now, there are an infinite number of different fractions that you could have. So basically, if you either multiplied or divided the numerator and denominator by the same number, by a giant 1, and you did the mathematics correctly, you will have equivalent fractions. Okay, so if there's ever a time if you feel like you're not sure whether or not you got these answers correct because you've got something different than mine, send me an email, give me a call, do whatever you need to do to check to make sure that you've got your equivalent fractions correct. Problem number 138. Jonathan measured 2 cups of flour into a bowl on the counter. Then he spilled part of it, and now there's only 3/8 of a cup left. How much did he spill? Okay, so this whole idea of spilling, let me change color here. The whole idea of spilling it implies a subtraction problem. And if you recall from our fact families, when we're doing these two subtraction sentences and the two addition sentences, remember the big number minus this is equal to 3/8, which means that 2 minus 3/8 would equal whatever that one was. And then if we wanted to, we could have said 3/8 plus this is equal to 2, or this plus 3/8 is going to be equal to 2. Well, the one that we're going to use that's going to help us solve this problem is that one right there, where we've got our expression and then our box for our answer is going to be all alone on one side. So how do we take 2 minus 3/8? Well, let's draw a model. Let's start with 2 circles. That's our 2. Okay, and I'm going to break each one of those into 8ths. Actually, I shouldn't have cloned yet. Let me do this. And now I shall clone. Goodbye. I don't want you. I want you cloned. Okay? So If you were to take away 3/8, let me go ahead and shade these guys in completely. And now if I'm going to take away 3/8, I'm going to take away 1, 2, 3/8. What does that leave me with? One entire circle plus 5/8. 1, 2, 3, 4, 5. So that is the answer to the subtraction problem. Now, how would we solve this if you weren't drawing pictures? Well, we would have to take 2 over 1 and take away 3 over 8, and we would need common denominators, right? So I would change this to 16 over 8, which is what we saw there, right? We took the 2, and each one of them were broken into 8, so you had a total of 16 eighths there. Take away 3 of those 8s, right? We just took away 3 of those 8s. That leaves you with 8, 9, 10, 11, 12, 13 eighths, which is the same as 1 and 5/8. Now, you could go on in another direction with this. Let me get rid of all that stuff. And let me put back my shading here. If you wanted to think about it in a different way, you could have just said, all right, I started with 2 full cups, and I spilled so much of it that all I had was 3/8 left over. So let's picture this where I've spilled so much. I've spilled an entire cup here, plus some more over there, and this is what remains. 1, 2, 3/8 is all that's left. So what do we have there? 1, 2, 3, 4, 5. 1 and 5/8 must have been spilled out. Okay, so once again, I said it in last time we were doing homework. I cannot stress enough how great it is to draw pictures to help illustrate what's happening within a math problem so that it makes more sense and you understand why we're doing what we're doing. Maggie, ooh, speaking of pictures, oops, no. Maggie is making muffins with a recipe that yields 18 muffins. There are 12 people in Maggie's book club. If muffins are divided evenly amongst each person, how much would each person get? Okay, so is this our 12? No, this is a different, that's for the other problem. So if you picture that, let's just start with these 12. And I'll erase in a second. So, no, we have 18, don't we? Yes, we do. We have 18. So that means that each person gets 1. So here's 1, here's 1, here's 1, here's 1, here's 1, here's 1. Here's 1, here's 1, here's 1, here's 1, here's 1, here's 1. So everybody gets 1, and then there's another 1, 2, 3, 4, 5, 6. We're going to have to cut each one of those in half. So you got 12 halves there. So each person is going to get a full one plus another half of one. So that's how each person gets 1.5 muffins. It says if Maggie wanted to divide the muffins evenly between 36 students in her class, how much muffin would each person get? Well, that's what this model is all about. So let me go ahead and get rid of all those. So you got 36 people, right? So that means that here they are. There's these 2 people get that muffin, 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 and so on and so forth. Basically, what we're doing here mathematically is saying if you had 18 muffins divided by 12 people, each person gets 1.5 or 1.5. And now if you've got 18 muffins divided equally between 36 people, then each person gets 1/2 of a muffin. Okay, did I draw the halfways going straight down so that they each get an equal amount? I could keep drawing and playing with this all day long. All right, multiple choice. If the probability of getting a particular result is 75.3%, then what's the probability of not getting it? Which one of these is the correct choice? And so the answer is C, because the total probability is 100%, right? That literally means everything that you've got that you're working with. So if you've got a 75.3% chance of getting something, and you're going to do a subtraction, and what is that going to end up being? 24.7% chance of not getting it. So this would be the approach to take there. And now, this is what we call a checkpoint problem. What this means is that at this point in 7th grade math, by the end of chapter 1, you are expected to have mastered the ability to find the area and perimeter of rectangles, parallelograms, trapezoids, and triangles. You should know what the formulas are, and you should be able to use those formulas properly. So this is what you need to do as a math student who needs to learn these concepts before you get into 8th grade and eventually into high school. You need to take the initiative. And there's a place where you can go if you're still struggling with some of these concepts. Let me go ahead and show you the answers first, so you can check your answers. When you go to your online book, do you remember when we went to the reference the other day and we looked at the glossary for the different shapes, the different quadrilaterals, or I guess they were polygons, right? Because there were some triangles in there as well. Well, there's also, if you scroll down further, oh no, it's right there. You got checkpoint problems. So if you click on the checkpoint problems, there is a checkpoint problem. Oh dear, you're going to take forever to open up. Oh, great. Thanks a lot. Let me see if I can do that. There we go. Okay. So this is the checkpoint problem for chapter 1 that we just looked at. These are the 4 problems. They show you what all the formulas are, and actually they kind of give you the answers too. But you shouldn't be looking at the answers. You should try and figure them out on your own. But this is after the fact. If you are struggling with any of these, and you can go to this page and they will show you examples on how to find area and perimeter of each one of those, and there will be a bunch of other problems that you can practice on. Okay, so this is a rectangle, find the area and perimeter of the rectangle. There's a triangle, find the area and perimeter of the triangle, and there are a total of 16 different examples there for you to work on. Use the formulas that are shown up here, and then you can check your answers to make sure you're getting those correct, okay? But this is where you have to take the personal responsibility. I know what you get right and what you get wrong on chapter tests. But as far as your homework is concerned, you've got to take ownership of that. And you've got to take ownership of whether or not you are fully mastering these concepts. Sometimes taking ownership is just taking the initiative to send me an email and ask for a little bit of extra help. Sometimes it's looking at these checkpoint problems, doing a little extra work. Sometimes it's talking with your parents and going on to Khan Academy and taking a look at some other lessons and seeing if maybe that makes more sense, and doing the practice problems along with the instructor on Khan Academy. Whatever it takes. But this is your education. You've got to take the initiative. You've got to make sure that you are understanding these concepts, because it's in your best interest to have these mastered, okay? I'm going to assume that you now know where to go so you can look and check out these formulas, and feel free to use your calculator along the way to help you find these answers. And if you have any questions on any of these problems, please do not hesitate to ask. Okay? All right, take care. Take care.
Hey, feeling good.